Okay, section 4, evaluate the limit by graphing the function on the xy plane. So our given function is negative square root of x minus 2 if x is less than or equal to 2. And our next function is x squared minus 2 if x is greater than or equal to 2. So in this sense, we graph our first given function, which is negative square root of x minus 2. Remember that just remember the square root of x on a graph would just be this from the x-axis. So it's from starting from the x-axis and continuing on based on the next value to it. So our next value would be negative minus 2. Instead of going to the left 2, you're going to the right. So you're starting from 2 and then you're going downwards since the square root is negative. If this was a positive, then you'd start from the 2 going downwards again. Okay, our next function is x squared minus 2. So then our y is negative 2. So we start here, and we just graph the function. 2 up, 1 here, 2 up, 2 up, 2 up. Sorry, this graph is a bit sloppy. We can fix this. Okay. So the function is x squared minus 2 if x is less than or equal to 2. We put this as undefined since it's less than 2, so there's no way of telling if it's actually 2. And so this is your graph function. And then the next question asks limit of x approaching 2 from the negative side. So from 2 to the negative side, we use the function x squared minus 2. And so we would have limit x approaching 2 from the negative side for f of x. We plug in 2 into x squared minus 2. So we have 2 squared minus 2. This is 4 minus 2, which is left with 2. So the limit of x approaching 2 to the negative side would be 2. And then our next one would be limit of f of x as x approaches 2 from the positive side. So from the positive side in this way, we'll use the equation negative square root of x minus 2. So then in this case, we plug in the limit, which is x approaching 2, the positive side of f of x. So then since this is a positive side, we use this function. So we have negative square root over 2 minus 2, which is negative square root over 0. This is the limit for this function. This is the limit for this function. Our last one to ask is limit of f of x at x approaches to 2. So we have a limit of x approaching to 2 for f of x. Now to find this limit out, you must remember that in order for a limit to exist, the limit from the negative side, so x approaching a from the negative side, must equal the limit of x approaching a from the positive side, which equals the limit of x approaching to a. That's how you know a limit exists. If the negative side and the positive side both equal, that's your limit. But in this case, both limits don't equal. The limit from the negative side is 2. The limit from the positive side is 0. So in that case, the limit for f of x as x approaches to 2 does not exist, because these two values don't equal up to each other. Our last question asks, does the function have any discontinuity? There is discontinuity, right at x equals 2. You see there's a non-removable jump from 2 and 0. This is where the discontinuity is at. And this is a non-removable jump. At x equals to 2. So here there's a non-removable jump which counts as discontinuity, which is another reason why the limit does not exist.